Hello and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence. We are looking at a massive shift in the AI landscape today. We're moving past the question of which model is smartest and entering an era where AI systems have their own wallets, they make real-world decisions, and require entirely new forms of human management. Let's begin. So I was reading this technical briefing this morning, and it honestly it kind of stopped me in my tracks.
Oh, yeah.
Yeah, because, imagine waking up to find out your teenager just bought a brand new sports car.
Right.
Now, imagine the teenager isn't a person.
Right.
It's just a line of code, and instead of a car, it autonomously rented like 10,000 servers in Tokyo while you were sleeping.
Wow, yeah.
It's terrifying, right? In AWS, Amazon Web Services, they just made something called Raw AgentCore Payments generally available. Okay, let's unpack this. Because giving an AI its own money just sounds like, the premise of a dystopian sci-fi movie. But it actually happening. These agents can now hold delegated spending authority.
Yeah, it really is a profound architectural shift. I mean, for the past few years, the defining characteristic of an AI was essentially a text box on your screen.
Right. Yeah, exactly. The chatbot window.
Right. You type a prompt, it gives you text back. And it was this incredibly smart digital brainstorming partner, but it was entirely contained in that window.
Safely in the window. Safely
in the window, exactly. But we are completely ripping that container open now. We're moving from AI as this passive software tool that you talk to AI as an active financial participant in the real economy.
Which is wild. And they're doing this using digital wallets, right? From Coinbase or Stripe Privy.
Yes.
So they can autonomously pay for data APIs or, unlock web content behind paywalls and even purchase raw computing power just on the fly.
Right, on the fly.
To me, it feels exactly like giving a teenager their first credit card. But obviously, you don't just hand over a limitless platinum card, right? Like there has to be some sort of control.
Definitely not. No, what's fascinating here is the programmable logic behind the money. You aren't just giving the AI a credit card number that it can, just copy and paste into a website. You are giving it a hyper-strict programmable sandbox. Think of it like a parental control system, but it's baked into the money itself.
Interesting. So like a spending limit.
Exactly. You might give an agent a hard $5 spending cap just for testing, but more importantly, the mechanism of the transaction is entirely machine to machine.
Oh, so it's not like typing in a Visa card.
No. It doesn't expose any raw wallet credentials to the open internet. It uses secure machine payment protocols to execute the trade cryptographically. So we are moving away from a software economy that is, based entirely on human negotiated monthly subscriptions.
Right. So instead of me, the human, realizing I need, let's say, weather data for my business, and then, calling a salesperson, signing a one-year contract, and putting my corporate card on file, the AI just handles it.
Exactly. Say the AI workflow encounters a problem. Let's say it's writing a supply chain report for you, and it suddenly realizes, oh, I'm missing specific real-time shipping data from a paid database.
Right.
Instead of stopping and sending you an email, asking you to go buy a subscription.
Which is what it does now. It just says, I can't access this.
Right, exactly. But now it just autonomously purchases the specific microtransaction required to get that data.
Wow.
It might pay a fraction of a cent for one single database query. We are looking at a future economy driven by millions of these machine-initiated microtransactions, and they're just happening in the background every single second.
That is insane. But if these agents now have wallets and the spending power to match, it makes me wonder where they're actually operating. Because they are clearly moving out of that isolated chatbot window.
Oh, they absolutely are.
Yeah, and I notice the major players are heavily pushing this transition. Like Google just put Gemini directly inside Chrome on Android with a feature called Auto Browse.
Yeah, that's a huge development. It means the AI isn't just giving you instructions on how to do something. It's just interacting with the web page exactly like a human would.
Right. You can tell it to book parking for a concert or manage your recurring grocery orders or, plan travel. And the AI actually navigates the website's interface to click the buttons and do it.
It handles the whole end-to-end task.
Yeah. And at the same time, OpenAI is expanding ChatGPT ads into 31 European markets, like places like Spain, Germany, France, Italy. They are embedding commerce directly into the consideration set. So AI is basically becoming a concierge that makes purchase decisions for you.
Right.
But as a business owner, how do you even compete when the AI is the one doing the shopping?
I mean, that is the existential question every consumer brand is grappling with right now because conversational interfaces they're basically collapsing the distance to the point of purchase.
How so?
Well, historically, search was a human funnel. You wanted running shoes, you searched, you scrolled through 10 blue links, you clicked a website, you navigated the store, and you checked out.
Right, the classic internet experience.
Exactly. But now the system acts on your behalf. It compares, it recommends, and crucially, like we just talked about with these new wallets, it can execute the transaction.
Right.
If a business isn't optimizing its data to be understood by AI logic, I mean, if you aren't in that AI-generated consideration set, you effectively don't exist in this new commerce loop.
That transition from just, recommending a product to actually acting on it is wild.
Yeah.
And it's not stopping at web browsers either. I saw that Gemini is being integrated into Waymo vehicles as an in-car voice assistant.
Yes.
Which, sounds amazing on paper. You get into a self-driving car, you talk to the AI to adjust the AC or ask for local restaurant recommendations. But I'll be honest, as a consumer, that makes me pretty nervous.
Sure, understandably.
Software has bugs,
Okay.
I don't want the AI that's recommending tacos to hallucinate and suddenly decide to take over the steering wheel. Like, how impenetrable is the firewall between the chatbot and the brakes?
Yeah, your hesitation is entirely justified, and it's precisely why the architecture of that Waymo integration is basically the blueprint for the entire industry right now.
Yep.
The conversational AI that's handling your AC and local recommendations, it is architecturally separated from the safety-critical driving system.
Okay, good.
Yeah, the Waymo driver, the actual system controlling the car, it remains completely independent. This strict separation of the intelligence layer from the execution layer is the foundational architecture for high-trust AI.
So they literally can't talk to each other in a way that would let the chatbot drive.
Right. You want the AI to be incredibly smart and helpful in its designated environment, right?
Yeah.
But you need an absolute physical and code-level air gap between its reasoning and the critical physical controls.
Okay, well, that makes me feel slightly better about the cars.
Yeah.
But if we have to build these massive, impenetrable firewalls just to keep an AI safely in a vehicle, it makes me wonder about deploying this in a corporate setting.
Oh, absolutely.
Because we are talking about letting AI operate autonomously, make independent financial purchases, navigate the web.
Yeah.
That introduces a massive amount of risk, which brings me to this headline I saw recently that I still kind of can't wrap my head around.
Which one was that?
OpenAI hit a pause on a major reinforcement learning run for their upcoming Astra model because early evidence showed it might reach their critical cybersecurity capability threshold.
Yes.
So wait, are we hitting a wall, not of compute power, but of governance? Like,
Right.
Are models actually getting too smart to deploy safely? Because that phrase, critical cybersecurity capability, is terrifying.
Yeah.
What does that actually mean?
It is a big shift. If we connect this to the bigger picture, the enterprise AI market is no longer constrained by raw intelligence. It is entirely constrained by permissioning, observability, and control. When OpenAI says critical cybersecurity capability, they are talking about a model's potential to discover and exploit software vulnerabilities autonomously and at a speed and scale that humans simply cannot track.
Okay, that is scary.
Right. Imagine an AI that can read millions of lines of code in seconds, find a zero-day flaw that literally no human has ever seen, and write a script to exploit it.
Oh, man.
When a model gets that capable, you cannot just push it live to a cloud server and hope your customers use it responsibly.
Right, because if it's that smart, a bad actor could use it to dismantle a company's entire network before anyone even finishes their morning coffee.
Precisely. Capability is absolutely advancing faster than safe deployability right now.
Which is crazy to think about.
It really is. And this is why privacy and governance are no longer just, legal footnotes buried in a terms of service agreement. They are the core product.
Oh, I see.
We're seeing OpenAI rolling out something called zero data retention, or ZDR, alongside a feature called private safety processing.
Okay, I saw that.
Enterprise buyers are demanding incredibly strict monitoring of these agents to ensure they aren't doing anything dangerous, right? But they also want absolutely zero vendor access to their sensitive data.
Wait, hold on. You're telling me OpenAI promises they aren't keeping or looking at a company's data with this zero data retention thing.
Right.
But at the exact same time, they are using private safety processing to monitor what the AI is doing. That sounds like a complete paradox. I mean,
No.
how do you monitor something for safety if you weren't allowed to look at it?
It does sound like a contradiction, but the mechanism behind it is actually this massive leap in cryptography and local processing.
Okay, how does that work?
So instead of sending the raw, unencrypted customer data, say, a bank's proprietary trading algorithms, back to OpenAI's main servers to be read and evaluated for safety violations, the safety checks happen in a secure, isolated environment.
Oh, I get it.
Yeah, the system essentially evaluates the mathematical weights and outputs of the model's behavior without ever retaining or exposing the plain text data to human reviewers at OpenAI.
Oh, wow. So they are checking the shape of the data, not the actual contents of the files.
Exact.
That makes total sense. Because if you're a major financial institution, you simply cannot have your AI reading unencrypted client portfolios and sending that home.
Exactly. And we are seeing this exact same governance bottleneck over at Microsoft and GitHub right now, too.
Oh, yeah.
Yeah, they are giving enterprise administrators incredibly strict central controls over Copilot in the JetBrains coding environment. They are actively putting systems in place to prevent software developers from bypassing approvals or, using autonomous autopilot behaviors unchecked.
Because even if you have the smartest coding agent in the world, an IT administrator is going to have an absolute heart attack if a developer unleashes it on the company's core code base without a centralized paper trail.
Oh, for sure.
You need to know exactly what was changed, why it was changed, and most importantly, who clicked approve.
That's the reality of enterprise software right now. The raw intelligence of the model is entirely useless if the enterprise cannot control and audit it.
Which brings up a really practical problem, actually. If companies have to put these massive, complex firewalls and safety protocols around every single action an AI takes, they can't possibly afford the compute power to run a giant, genius-level model for every tiny task.
Yeah, definitely not.
It's like hiring an expensive world-class general contractor who charges $1,000 an hour and asking them to fix a leaky faucet instead of just calling a local plumber.
That is a perfect analogy. Companies aren't just plugging one massive, expensive model into everything anymore. They are having to orchestrate multiple systems, routing different tasks to different specialized tools based on permissions, complexity, and obviously cost.
Is that why Stripe just bought OpenRouter? Because I saw that acquisition news.
Yes.
And OpenRouter is a system that dynamically routes user requests across, over 400 different models.
Correct.
And the stat that blew my mind was that it processes 10 trillion tokens a day.
Yes. Stripe's acquisition of OpenRouter is a massive signal to the market. I mean, Stripe handles internet payments. They deal in financial infrastructure. By acquiring OpenRouter, they are acknowledging that routing AI tasks is now core economic infrastructure.
Wow.
And to understand why, we have to look at what those tokens actually represent.
Yeah, because for anyone who isn't living and breathing AI infrastructure, what does 10 trillion tokens actually look like? Like, what are we measuring here?
Think of a token as a piece of a word. It is the fundamental unit of computation in an AI model. Every time an AI reads or generates text, it burns tokens, and those tokens cost money.
Okay, got it.
So an inference provider is essentially the data center factory that processes those tokens. So model routing is fundamentally an economic decision. It's about optimizing the cost per token for every single interaction in real time.
So going back to the contractor analogy, OpenRouter isn't just hiring the plumber. It's a system that takes my leaky faucet request, instantly looks at the hourly rates of 400 different plumbers, realizes it's a simple job, and dynamically routes the task to the cheapest, fastest option available at that exact millisecond.
Exactly. You wouldn't use your most expensive, heavy-duty reasoning model just to, say, reformat a date column in an Excel spreadsheet.
Right, that's a waste of money.
It's a huge waste. You'd route that to a cheaper, faster model. That real-time dynamic routing is becoming the new backbone of enterprise AI.
But it's not just about routing the task to the right model, right? It's about giving that model the right context to actually do the job without messing it up.
Absolutely.
Which brings me to what Anthropic and Slack are pushing right now. They are creating this new architecture where workplace conversations aren't just chats that disappear when you close the window.
Yep.
They become persistent context for human agent teams. And Anthropic also just made their enterprise user management APIs generally available to support this. So the AI isn't just, dropping into a conversation cold. It actually understands the history. It understands the why behind a decision, not just the what.
That distinction between the why and the what is vital. Proprietary context, like understanding exactly why an organization made a specific decision a month ago, is becoming far more valuable than a generic, perfectly engineered prompt.
Because it actually knows your business.
Right. Let's say an AI agent knows that your engineering team decided against a specific database migration last quarter because it caused a massive latency issue. It won't suggest that same migration again today.
Oh, that's smart.
That institutional memory is what turns a generic, off-the-shelf AI into a deeply embedded, highly valuable team member. The durable advantage for companies in the future won't be the model itself, because honestly, everyone will have access to smart models. The advantage will be the accumulated knowledge and context they wrap around it.
Okay, so if we have perfectly routed, context-aware agents doing all this autonomous work, right? Paying for things with their own wallets, navigating the web, remembering our past decisions, the sheer volume of output is going to be staggering.
Oh, completely.
Which really makes you wonder, what is left for the human worker?
Yeah.
I saw this report from Anthropic about their Claude model doing chemistry.
Yeah, that was fascinating.
They mentioned it designed protein binders against 14 of 15 targets, and it processed raw NMR and LCMS chemistry data in just 19 to 23 minutes. It matched the analysis of Ector Contract Labs. Now, I have to admit, I am not a chemist.
Right. Most of us aren't.
I have absolutely no idea what those acronyms mean, but the report treated it like a moon landing.
It really is a massive breakthrough. So NMR stands for nuclear magnetic resonance, and LCMS is liquid chromatography mass spectrometry.
Okay, sure.
Yeah, without getting too deep into the weeds, think of these processes as taking a complex chemical mixture, smashing it apart, and looking at the microscopic debris to figure out exactly what molecules are in there.
It sounds complicated.
Extremely. For a human chemist, processing this means staring at massive, incredibly complex graphs full of peaks and valleys, calculating molecular weights, and reverse engineering the chemical structures. It normally takes teams of highly trained human experts weeks to complete this analysis.
Weeks?
Weeks. Claude did it accurately in roughly 20 minutes.
That is just... Here's where it gets really interesting, because that scale of compression isn't just happening in chemistry. OpenAI published an Asana case study showing their Codex agents tackling the migration of an obsolete testing system. Asana's internal projection for this project was that it would take a 5-year staffing plan and cost roughly $6 million.
Yeah.
5 years and $6 million. The Codex agents compressed that entire migration down to roughly 2 weeks, and it cost about $12,000 in compute costs.
Yeah.
Let that sink in. I almost couldn't believe those numbers when I read them. If AI could do 5 years of engineering work in 2 weeks, the entire bottleneck of human progress shifts completely.
It's hard to overstate the impact of those numbers. This raises an important question about the fundamental nature of work moving forward.
Yeah, I'll say.
If we look at the ultimate market pattern unfolding right now, the economy is moving through 4 distinct phases: generation, execution, transactions, and finally, verification.
Okay, break that down for me.
Sure. Producing massive amounts of code, writing text, or designing complex molecules, those are the generation and execution phases.
Right, which the AI is doing now.
Exactly. It's now incredibly easy and cheap. The true defensible moat, the absolute scarcity in the market right now, is validation.
So what does this all mean for the person sitting at their desk tomorrow morning? Are they out of a job, or is their job just fundamentally different?
Their job is fundamentally different. It means humans aren't generating anymore, they are verifying.
Wow.
The bottleneck is no longer typing the code, it's as the expert code review. It's the wet lab testing to ensure the AI's protein binder actually works in a physical reality. It's the fact-checking, the legal review, and the final human approval. The AI can migrate a testing system in 2 weeks, but human engineers still have to sit down and review every single proposed change before it merges into the live production environment. Validation is the scarce resource of the future economy.
It's a total inversion of how we've worked since the Industrial Revolution. We used to spend 99% of our time making the thing and 1% checking it.
Yes.
Now the machine makes the thing instantly, and we spend all our time verifying it's actually correct and safe.
Exactly.
Which leaves me with a final thought to mull over. If human verification is the only bottleneck left in this new economy, what happens when we start training specialized AI models whose sole purpose is to verify the verifiers? When the human review process becomes too slow for the speed of AI generation and we build machines to audit the machines in a fully automated machine-to-machine economy, who watches the watchers? That's all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe, and join us next time for the latest in AI. Until then, keep building what outlives you.